Hello, my name is Daniel Milner, but for the next 4 or so minutes my name is Andreas Morgensen, commander of the Expedition 70 crew here on board the International Space Station. I'm going to be taking you for a whistle-stop tour, starting here in the Harmony module, to discuss some upgrades and recent activities since Sonny Williams' tour of the station that I know you're all familiar with. Oh, and here is our mission patch. Let's talk about my arrival to the ISS as pilot of the SpaceX Crew Dragon capsule. We docked at the Zenith port on the Harmony module. At the time of the recording, the ISS has 5 spaceships docked. The docking process is shown alongside an animated version. The Crew Dragon approached from what's known as Waypoint 0, 400 meters directly below the ISS, before accelerating to Waypoint 1, 220 meters in front of it, and finally effectively slowing down to enable docking with the station behind it in orbit. During the slowing period, thruster firings are made to maintain lateral motion and prevent dropping into a different altitude. There is ongoing research into improving current space station docking systems, which are extremely mechanically complex and have very strict pointing and control requirements. One alternative is a flexible electromagnetic leash docking system, or FELDS, recently developed at the University of Padova in combination with Airbus Defence and Space. This suggests an electromagnetic soft docking system that guarantees a mechanical connection between two spacecraft through the use of a flexible cable.
You have joined me on the left-hand side of the spacecraft in the Japanese Kibo laboratory attached to the Harmony module. We have been working in the Life Science glove box, where we are currently looking at both ovarian function in female mice in microgravity and also the relationship between bone loss during spaceflight and altered estrogen signaling. This glove box is sealed and held at negative pressure compared to the crew's living area to isolate the station from possible hazards associated with the investigations that are taking place inside.
It supplies live video downlink with scientists on Earth, enabling crucial research such as this to be monitored.
Across in the European Columbia Lab, work is being carried out using the Space Automated Bioproduct Labs, which are incubation units that enable science and physics research at controlled temperatures. An added benefit of these units is the capability to efficiently recharge NASA's cold bricks, which are critical for carrying scientific samples to and from the ISS at specified temperatures. Let's move through Node 2 onto Columbus. Ooh, here's one of our Russian cosmonauts, Privet Nikolai. I'm engaged in 2 sleep-related experiments in sleeping quarters such as these here in Node 2, Circadian Light and Sleep in Orbit, which seek to address the challenges faced by astronauts in keeping a natural rhythm on board the ISS. For example, I've installed this light which is synchronized to my daily schedule as part of the Circadian Light experiment, and my sleep and performance are monitored to observe the impact. The colours of the light have been carefully selected to mimic the natural light of day on Earth. Over the past few years, crew on board the ISS have been performing spacewalks to carry out power and thermal upgrades. The European Robotic Arm, which arrived in July 2021, has recently been employed to move larger items, such as this video of a radiator being attached to the Nauka Multipurpose Laboratory module during Roscosmos' spacewalk last April. In 2023, ISS Rollout Solar Arrays, or IROSA, 1A and 1B, were launched and later installed, augmenting the ISS's 8 main solar arrays which have degraded over the years. These represent the 3rd pair of IROSA arrays installed since 2021, with each pair producing 20 kilowatts of power, a 30% increase compared to current arrays. Hence, although they are installed on top of the existing arrays and therefore shadowing them, there is still a net increase in power. The installation of each solar array requires 2 spacewalks, one to prepare the worksite with a modification kit and another to install the new solar array.
The technical lifetime of the ISS is limited by the integrity of the primary structure. When the spacecraft does eventually reach its end of life, international space stations will continue to grow in scope, since conducting a fully independent, large-scale space effort is still unfeasible for most countries, but it'll be interesting to see how this develops over the next few decades. I've been Andreas Morgensen, and thanks for joining me on board the ISS.